Hello class, Mr. Hasty here. Today we're going to be starting section 9, which deals with waves. And we're going to start with talking about the characteristics and different types of waves. So first of all, what is a wave? A wave is defined as a repeated disturbance transferring energy through matter or space. A lot of different things we know are waves. We think of waves in the ocean, we think of sound waves. Light is also a wave. Some waves require matter to transfer through, and some don't. The ones that don't, we say transfer through space. If they do require matter, we say that they have a medium. A medium is the matter a wave travels through. So if we're thinking of a wave in the ocean, the water would be the medium. For a sound wave, air is typically the medium we are considering. Types of waves that require a medium are called mechanical. Mechanical wave is any wave that requires a medium. And that means not only does it require, specifically that means it requires matter to move through. So examples of waves that would be sound and water waves, but light does not need a medium. Light can travel through empty space. So we're going to talk about two major types of waves, transverse and longitudinal. A transverse wave looks like what we have down here. Definition of a transverse wave is a wave that moves perpendicular to the medium. So if you remember, the word perpendicular means at a 90-degree angle, at a square angle. So if we look at this wave down here, the material, like the water, is really moving up and down, but the energy is moving along the direction of the wave. So the energy is moving one direction where the matter moves at a 90-degree angle of that direction. One of the things we're going to talk about is when we look at a wave, there's a lot of different terminology. For instance, the high point of a wave is called the crest, whereas the low point of a transverse wave is called a trough. If we think about it, the flat line in the middle, right here, would be where the natural state of this medium is. So if we think of a flat pond of water, when we drop the rock into the water, the wave will create ripples. Now, how high or low you get from that baseline is called the amplitude. And that's really the distance you go from the baseline, from the normal position. Another term we're going to have is that of a wavelength. A wavelength is the distance between two similar points on a wave. So if we look at this trough right here and this trough right here, the distance between them is called the wavelength. And you can pick any 2 points. If you pick the base point right here, the next base point that has a similar property that's going downward would be right here. And that would be the wavelength as well. And those would be the same distance. This also brings up the concept of a period. A period is the amount of time it takes a wave to travel its wavelength. So, reviewing the major properties, crest is the high point, trough is the low point, amplitude is how far up the crest is from the normal position or how far down the trough is from the normal position. The wavelength is the distance between similar points, and the period is how much time it takes to cover that wavelength. So that encompasses transverse waves. Longitudinal waves look more like this. It looks like a slinky where you shake one end, allowing it to kind of mush together and spread apart. The areas where it mushes together are called areas of compression. And the areas where it spreads apart are called areas of rarefaction. So compression is tight together, rarefaction is spread apart. In this diagram, let's define longitudinal waves first. A longitudinal wave is a wave where the energy and matter move in the same direction. So in this case, the energy is moving this way and the matter is moving that way. Now, if we look at a diagram like this type of diagram does not have an amplitude in the same way that a transverse wave does. But it does have a wavelength and a period. So the wavelength is still defined the same. If we find a point and a similar point, the distance between them is the wavelength. So if I pick the point here where it's most compressed and the point here where it's next most compressed, that distance is our wavelength. The time it takes to cover that distance would be called our period. Even though the amplitude isn't the same as a transverse wave, it still does have amplitude. The amplitude affects how tightly compressed or spread apart the regions are. The more extreme the compression and rarefaction, the higher the amplitude. Now, let's talk about a few types of waves that we're used to seeing and categorize them as transverse or longitudinal. So, one type of wave is your typical ocean wave or any kind of water wave. Those would be transverse, also referred to as T waves. Light we talked about as a wave, and light is actually part of a bigger group called electromagnetic waves, and those are transverse as well. Talked about sound waves. Sound waves are mechanical waves, and they would also be longitudinal. And finally, seismic waves, the kind that are made by the earth that generate earthquakes, can be either longitudinal or transverse. Now, in terms of which of these are mechanical, ocean waves travel through water, so they're a mechanical wave. Light and all electromagnetic radiation are not mechanical. They do not need a medium. They do not need matter to travel through. Sound is mechanical. Typically, we think of sound waves traveling through air, but they could also travel through liquids or solids as well. And seismic are mechanical. They travel through the earth. All right. And that covers our introduction to waves. See you next time.